going to talk more particularly about narrow bandpass filters. We saw earlier this morning, if I have a high index quarter wave and then a half wave, at a half wave everything's going to go as though there was no coating. If I get a high index like germanium, now I'm going to have a high reflection in here. But again, at the half wave, nothing. So since we're only talking numbers here, we don't have to talk about real materials. We can imagine an index of 8 or 16 or 32, but they're not real materials, in our spectral region at least. But it's only numbers. We can do anything we want. Put it in a computer. Don't have to make it yet. But the interesting thing is if I turn that chart upside down, all of a sudden what I've got is a filter which passes this narrow band. So this is the basis of the narrow bandpass filter. So what do we have here? If I have a slab of very high index that happens to be a half wave thick, because this is a very high index in air, this is a very high reflector. And similar to this side, it's like the other side of the soap bubble. Again, a very high reflector, and this soap bubble is now index 10 or 20 or a million, whatever. So these are very high reflectors separated by a half wave spacer. So my layer is a half wave thick, or 2 half waves, 3 half waves. Any number of half waves, the same thing will happen. So the basis of a narrow bandpass filter is a high reflecting surface, a half wave spacer, and a high reflecting surface. And the first ones that these were made was probably Gefkin in 1939, where they put a partial reflecting layer of silver, a spacer layer, half wave thick, and then silver on the other side. Of course, the silver only partially transmits, partially reflects. So you weren't getting a 90% transmission filter. You maybe get a 30% transmission, but it was a narrow bandpass filter. Harry Polster, who was the guy I worked for at PerkinElmer in '57, I found out much later, was attributed with making the all dielectric narrow bandpass filter that I'm going to describe. One way to make this, of course, is partially reflecting metal, but we know how to make a mirror with dielectric materials, these quarter wave stacks. So I could put a quarter wave stack over here as a mirror, and a quarter wave stack over here as a mirror. And all of this then is non-absorbing material. It's all dielectric material. And yet you look at it and it looks like a very high reflector, except at the one wavelength.